All right. Let's start from the beginning then. What is organic chemistry? Does anybody have an idea of how we define it? What do you think?
It involves compounds that have carbon.
Yeah, that's a great definition. Anybody else have a slightly different one or variation on that? And hydrogen? Hydrogen is important. All right, so let's go through the history of this a little bit. Prior to 1830, they didn't really understand much about atoms. They knew things were composed of atoms, but they were still understanding just the basics behind them. And so they defined organic chemistry as derived from living things. Oh. And I was actually reading a book about it this summer, and the thing that made me laugh was they called it a vital force. Organic things had this mysterious vital force in them. It made me think of Star Wars. They realized later that this wasn't necessarily true, that you can actually make organic molecules from non-organic things. So you can take things like inorganic salts and convert them into organic compounds. So there's not any mysterious vital force in organic compounds, but they are involved in a variety of living things. Today, the modern definition involves carbon. So they are carbon-based compounds. The term organic gets misused on a regular basis. If you go into the grocery store today, you see it around you, right? The joke I like to make is when you see the organic fruit, you say, I wonder where their inorganic fruit is. Just a big pile of rocks in the corner or something. A lot of people say organic is healthy and natural and good for you. The reality is some of the most potent toxins and poisons in the world are organic, right? So snake biting you could kill you in 3 seconds. That's an organic compound. Organic doesn't necessarily mean better. It's just talking about something that's primarily made of carbon. All right, the question now that I have for you guys is, why is carbon so special? So I want you guys to try chatting with a neighbor and try to come up with at least 2 ideas for what makes carbon so special. Why, as opposed to nitrogen, is carbon so special? Why, as opposed to lithium, is it so special? So talk with your neighbor. All right, let's try to come up with a short list, you guys. Does anybody have an idea they want to throw out? What do you think? It makes 4 bonds. That's a great one. There aren't very many atoms that can make 4 bonds, right? So it can make 4 bonds. They can be single, double, triple, and we'll talk about those. So it's pretty unique in that it can do that. Yeah. Anybody have a different idea? Yeah?
High relative abundance.
Yeah, it's relatively abundant. Anybody have a different idea? Yeah?
It can form chains with itself.
Yeah, it can form chains. I'm going to add something else to that. It forms really strong bonds. Do any of you guys have a diamond wedding band or a ring? A few people do. You don't have to advertise it. Diamond is made of carbon, right? Diamond's the hardest substance on the planet. Carbon makes really, really strong bonds. I'm sure a lot of you guys have heard about graphene or carbon nanotubes. People are really into those right now because they're incredibly strong, stronger than steel. Carbon is very unique that way. Anybody have any other ideas? Yeah?
Thinking about its electronegativity, maybe.
Yeah, we'll talk about that. Carbon's kind of in the middle of the electronegativity sequence. But it is unique because of that. It doesn't want to steal electrons. It'll share electrons and form covalent bonds, and that doesn't make it unique. So we'll add that. Forms covalent bonds. The last one I'm going to add in too is that it's present in all major biomolecules. Actually, let me rephrase this. It forms the backbone of biomolecules. I get a lot of students here that are pre-health. I'm sure most of you guys are pre-health in some way, shape, or form. And a lot of them say, I'm going to be a doctor. Why do I need to know organic chemistry? It makes me cringe. Our bodies are chemical machines, right? Everything in us, from our DNA to our proteins to our fats, are made of carbon. You have to understand organic chemistry if you're going to understand how living things work. My favorite quote is, biology is really chemistry, chemistry is really physics, and physics is really math. You can't understand one without knowing the other, right? That's why you guys have this wonderful load that I'm sure most of you are experiencing now. All right, so now let's talk a little bit about this guy. This is Gilbert Lewis. He is the grandfather of organic chemistry, or the father, depending on... Oh. Let's see if my pen will work. Oh, there it goes. Gilbert Lewis. Gilbert Lewis was the first chemist to come up with the idea of a covalent bond. What does it mean when something's a covalent bond? It shares electrons. So he defined a covalent bond as a bond where two electrons are shared. Do you guys ever feel underappreciated? This is just a subjective question, I guess. This guy was like the most underappreciated chemist that's ever lived. I looked up a little bit about him. He was nominated for the Nobel Prize 35 times and did not win. Yeah, right? So what other things is Gilbert Lewis known for? Does anybody know? Focus on the last name. Dot structures, acid spaces. So Lewis acid-base theory, he came up with it. He came up with modern thermodynamics. He came up with a lot of the early photochemistry. He came up with isotope separation. He came up with valence bond theory. I mean, this guy knew how to do it all. He did not win the Nobel Prize. All right, I'll explain why. This is why you want to be friends with your German colleagues, right? Walther Nernst, do you guys remember the Nernst equation from general chemistry with batteries? They were lifelong enemies. Nernst won the Nobel Prize and was on the committee and blocked him every single year. The sad thing with Gilbert Lewis is he was pretty irritated by it. He lived his life as a pretty unhappy man. And he actually ended up committing suicide, they believe, in his lab because he was so kind of ticked off that nobody appreciated him. So if you ever have days where you feel like you're kicked down, just remember Gilbert Lewis had it worse. All right. And he came up with the valence bond theory, which is very important, right? What is a valence electron? Yeah, it's in the outer shell. So let's do a brief review of valence electrons. I know most of you are familiar with this. But I know some people haven't taken chemistry in a few years, so we're going to review it. They are the outermost or highest energy electrons. So the easiest way to remember the valence number, or the number of valence electrons in an atom, is to look at the periodic table and look at the main group number. So hydrogen has 1, Beryllium has 2. We go over to boron. It has 3. Carbon has 4. Nitrogen has 5. Oxygen has 6. Fluorine has 7. So you can use the last digit there to identify the valence number. So Gilbert Lewis identified that these valence electrons really prefer to bond to other valence electrons. And he came up with the system of drawing out atoms because of that. So we said that hydrogen has 1 electron. So he identified that electron with a dot. Boron had 3 electrons. So we do 3 dots around it. Carbon has 4. So we put 4 dots around it. And then nitrogen, oxygen, fluorine, and then I'll just do helium over here. Right, so he just started adding in dots representing electrons around these. But the key thing that he noticed was that electrons really aren't happy when they're paired, or when they're unpaired. If you look at oxygen over here, we got 2 of them that are paired up on the left-hand side and that top side, but the electron on the bottom and the electron on the right are unpaired. That makes it relatively unstable. So he noticed that electrons want to be paired. And there are 2 ways that electrons can be paired, right? You've got the bonding between 2 electrons. What's the other way that they can be paired if they're not in a bond?
Give up. Lone pairs.
Lone pairs, right? If you give up an electron, it'll become a lone pair. So that's the really important thing, is that when they're paired, they're either going to be involved in a covalent bond or they're going to be a lone pair. So he used this to form something called Lewis dot structures, right? So let's do a brief review of that with the couple minutes that we have left.
What's the difference between a covalent and lone pair?
So if you think about a covalent bond, it's 2 electrons shared between 2 atoms. A lone pair is just 2 electrons hanging out on an atom. They're not being shared, right? So if you think about water, water has 2 lone pairs on the oxygen, and then 2 sets of shared electrons to each hydrogen, right? Yeah. So let's do a review of Lewis dot structure, and we'll see this a bit more. I'm sure most of you have had this pounded in your head for the last however many chemistry classes you've taken, but we're just going to do a brief crash course. And the first rule is that electrons want to be paired. What's another important rule when doing Lewis dot structures? Yeah. So atoms prefer to have 8 electrons. The one thing that kind of ticks me off is books will say that it's the octet rule. It's not a rule so much as a suggestion, right? If we look at hydrogen, are you ever going to fit 8 electrons around hydrogen? No. Boron, it's fine with 3. It has 3 valence electrons. In fact, it'll form trigonal planar compounds, so it's okay not following the octet rule. This is just a general guideline. You don't really see atoms that have more than 8 electrons. That's a really big rule. So not more than 8. All right, the last thing is you want to include formal charges. What does it mean when something has a formal charge? Yeah, it's not neutral. It's either a cation or an anion, right? So let's do our first practice one really quick, and then we'll head out. So let's do CH4, methane. How many valence electrons around carbon? 4. So I draw it out like this, Lewis dot structure. Then we've got 4 hydrogens. How many valence electrons for each of them? 1. So we can go through and we can say, oh, okay, whoops, I forgot 1 electron here. I'm going to pair up these 2 electrons. They'll form a covalent bond. These 2 will form a covalent bond. These 2 and these 2. And when we draw the Lewis dot structure, we can draw the shared pair of electrons as a line. And so you get carbon with 4 bonds, each to a hydrogen. If this sounds super duper foreign to you, I would really recommend going to the Khan Academy link on the course website and maybe do some review of Lewis dot structures. We're going to practice some more tomorrow, so I don't expect you to be an expert in them, but this just sounds like Greek. Try to watch some of those videos. Remember, if you have Monday lab, we're going to have lab up in 324L, and remember to grab your problem of the day on the way out. It's due tomorrow at the start of class.